Welcome back everyone to Coding for Beginners. In this program, you're going to enter 3 points as XY coordinates. You're going to make sure the points aren't all in the same line, because if they're all in the same line, you can't form a triangle. And you're going to ensure that the user enters values that are actually numbers instead of letters or extraneous characters. The application should calculate the area of the resulting triangle from the 3 points you entered. Thanks for joining me, and let's get going. So here we are back in IntelliJ IDEA, and I'm going to start a new project. And we can call it Triangle Area. And to give you an idea of what we're building towards, let me pull that up to show you the end product. A window, let's say I enter point 3, 0, 0, 3, and 0, 0. This is a triangle centered at the origin of a normal XY coordinate plane, and you hit calculate area, and down here it should tell you what the triangle area is, in this case 4.5. You can clear the form. If you hit, say for example, you accidentally put the letter A in one of them and you put a bunch of numbers somewhere else, it should say, please enter numeric inputs only. So let's see how we can get started. Back in IntelliJ IDEA, I'm going to click on New Project, and it's going to be a Java 17 project, next, and I'm going to call this Triangle Area, and I'm going to click Finish. But instead of Java class, this time what I want to do is use the Swing UI Designer and click GUI Form. Make sure Create Bound Class is checked. I'm going to make the form name Application, and Base Layout Manager, we can do Flow Layout, and that's just how components are placed on the screen. Click OK. And so this creates this panel for us, and I'm going to give the panel a name. Let's call it Main Panel. Now this creating this form created a .form file, and it created the application.java file. As soon as I put a panel on here and gave it a name, if you go to application.java, it automatically created the public class called application, same name as the form, and it created a field, private jPanel main panel. What we need is several components to go onto this frame, but show expert properties down here. You want to click this, and what I'm going to do is set the preferred size, let's say 100 by, set the minimum to the same thing. Doesn't make any difference, but that's basically what I want it to look like. And then I'm going to create a label at the top. So I'm going to choose a J label. Go over here to where it says Swing Palette here on the right, and I'm going to click J label. Once you click it, you go here and you place it. And I want it to read enter 3 points. And then I'm going to take this header and I'm going to change its dimension to 190 by 30. Let's add another J label. Well, first let's go back to this one, and we're going to call it header label. And this one, point A, colon, space, and we're going to call this point A label. We need the point AX label. X with a space maybe. That field will be point AX label. Finally, a J text field where the user can actually enter an X value, and that's going to be point AX text. And then we're going to repeat this with the Y coordinate, J label Y, colon, space, point A Y label. We need a J text field, point A Y text. So we're going to repeat what we just did 2 more times for point B and point C. I can now place the output panel. So I'm going to take a J panel again, and I'm going to make the output panel about 200 by 60. And I'm going to call this an output panel. And inside it's going to have a couple of things. First of all, it's going to have the button. What we want is the calculate button, so we need a J button. I'm going to click button, calculate area. The next thing we want is a JText pane where the result will be presented, the area, 200 by 30. Finally, we need a button to clear all of the fields. I'm going to make the main panel center align again, so that this button here shows up in the center. Clear form. We do need to assign names to all these items. So this is the output panel as the button, and we're going to call this the output pane. So all of the things we need on the form are there, and if we go to the application.java file that's automatically generated, all of those components are now automatically entered into the application class. Extend the JFrame class We don't need to import anything because JFrame is part of the Swing framework, and we've already imported everything from Swing, as you can see from import, which was done automatically when we created the form. And what I want to do is call upon the JFrame's super constructor, but to do that, first I want to create the constructor for application. Super will now call the JFrame constructor, and I want to give this thing a title. And we're going to call it triangle area. I'm going to create the application as a JFrame. And so the next thing I want to do is set some properties of this frame. I can set the size to, let's say, 230 by 285. Set the default close operation to exit on close. Set resizable to false because I don't want someone resizing the window of the application. Set location relative to null, and which will center the JFrame on the screen. To add a listener to, so that it adds functionality, I can go to that button, right-click, create listener. And what I want is an action listener because the action I'm listening for is someone clicking on this button. Click OK. And so that will automatically, in application.java, create a listener for the button. As you can see, it says calculate area button, add action listener, new action listener, public void action perform. So we saw this in the last video. This created an anonymous class here. All you need to do is tell it what to do when you click the button. We did this in the last video where when we clicked a button, a JOption pane message dialog showed up. But now what we want this to do is calculate the area of a triangle based on the points that someone enters into the boxes above. So let's take a moment here before we start programming that to understand what we're going for. So imagine you have a triangle like you see on the screen here with points A, B, and C. And suppose that these points, -3, 3, 0, 5, and 5, -2, as you see on the screen. Then how would you find the area of this triangle? One way is to get the length of one of the sides and the height of the triangle from the opposite angle. So for example, if h represents the height, it would go from angle B down to side AC, which I've labeled as lowercase b. So 1/2 b times the height would give you the area. But how on earth do you get the height? You'd have to find the slope of AC, you'd have to take the negative reciprocal of that slope to get the perpendicular slope, and find the line that goes through B with that slope and where it intersects line AC. If you didn't understand that, don't worry. It's just a lot of calculations to do. But is there another area formula we might be able to use? Well, yes, there is, and it's going to be based on finding the distance between 2 points. And you find the distance between all sets of 2 points in a triangle. It will give you the length of each side of the triangle. Then you can find the area with the length of each side, as I'm going to show in the next few slides. But first, the distance formula is this. It's basically subtract the x values, you square that. You subtract the y values of the 2 points, you square that. You add those two together, and then whatever you get, you take the square root, and that's AB. That's the distance between 2 points. If that looks familiar, it should, because it's essentially just the Pythagorean theorem. And in this example, I've worked it out here. As you can see, you have 4 minus -1 for the 2 points, x points, and 2 minus 4 between the 2 y points. We square those, add those together, take the square root, and I get 5.39 in this case. And then here's a visual that shows why that's the same as the Pythagorean theorem, because if you look at the 5 there on the dashed line, it's essentially showing you that the x distance between the two AB points is the distance the 4 minus -1 is 5, and then you go straight up from there, always in a right triangle sort of formation, to go from one point to the other, and that's why it's the Pythagorean theorem really in disguise. So once you have that, you can use Heron's theorem, and it's shown here, to find the area of a triangle given the 3 side lengths, A, B, and C. You just take the semi-perimeter, and that's basically the perimeter, A plus B plus C divided by 2, and you multiply it by the semi-perimeter minus the first side, then the S minus the second side, and S minus the third side. You multiply all those together, and you take the square root according to this formula, and you should have the area. And for the example given earlier, -3,3,0,5,5, -2, using this formula, you would get an area of 15.5. Back in the application.java file, what I can do is start planning out how I want to do the calculations and find the area of a triangle given the 3 points that a user entered. Well, first, let's think about this in terms of objects, because that's, after all, what we're doing here, object-oriented programming. We have points entered by the user, and we want to find distances between them, to find the lengths of sides of a triangle. We want to find area. But we already developed a point class in a previous exercise, and I'm going to paste that entire class into this file, and that's fine. You can actually define multiple classes in the same file. We haven't done this before. We put every class into its own file, and we could certainly do that here. And we want to be able to solve something using the point class. We want to be able to find the distance between two points. How do we go about doing that? First of all, do we want the points to be integers only, or will we accept double values? I'm going to allow people to accept double values, so I'm going to go ahead and modify this entire class so that it accepts double inputs, it returns double inputs. The next thing I'm going to do is create a function, the distance2 function, and it's also going to be a double distance2, and it takes as an argument another point, and I'm going to call it point B. So if you wanted to call this function, you would have a point object already, and then you would say that point object, let's call it point A, and you would say a.dist2, and then put as an argument another point, and it should return the distance between those 2 points. We can use the square root function from the math package, which you don't need to import. So math.square root, and it takes double as an input, and in this case, we need math.pow for power of this point's x value minus the point you entered's x value squared. So that's what pow does, power. It takes that difference, this.x minus b.x, and squares it. And then you're going to add to it math.pow, this coordinate's y value, subtract the coordinate you entered, its y value, squared. And you're taking the square root of the whole thing, as you can see on the outside. This is the implementation of the formula I showed you earlier, distance formula. Now that we have the point class incorporated with the additional distance2 function, I can go ahead and start taking the user inputs. Remember that if you're going to take user input, you probably need a try catch block to allow for user input errors. So I use try, and we're probably going to catch, as I explained before, in a previous video, you're going to catch something, and that something was a number format exception, and we'll call it E. And actually, we want the number format exception to have to be identified with EX and not E, because if you look up here, the action event is already defined as E in this function. Now what we want to try is to get those inputs from the user. So we want them all to be double. So we say double, let's say A's x value, we'll call AX, equals double dot parse double, because the inputs will be in string format. And we'll say point A's x text dot get text. And that's how you get the text from the input that the user gave. So I'm going to do this again for the y value, and then for B's x and y values, and then C's x and y values. The inputs converted to double, I can create point objects out of all of these by saying point A is equal to new point AX, AY. And so that creates 3 point objects using the point class as constructor. Finally, we're going to return the area, and we're going to use another function. I'm going to say double area is equal to get area, and I'm going to pass it, and I haven't created this function yet, that's why we're getting an error. I'm going to pass it the 3 points. So I'm going to hold off on writing the get area function, but let's assume that we got the area. And what I want to do now is think about this for a second. One of the things that we need to do is make sure that the user didn't enter 3 points that are in the same line. For example, the coordinates 0, 1, 0, 10, and 0, 5 are all on a vertical line, and therefore you can't make a triangle out of that. Let's say we want to make sure that that hasn't happened. What we can do is the output string, and this is a new concept called the ternary operator. It's basically a shortcut to an if-else statement. Create a string and give it the name area string. In other words, what we output once we get the area is equal to, first check if area is equal to 0. And the reason I'm saying 0 is because if all of the points are in the same line, I'm going to have the getArea method indicate that by returning an area of 0. So if it's 0, then what I want it, and use the question mark, you can write not a triangle. Else, and that's what the colon is, get string.value of, and then you want to round the area to 4 decimal places. And round is another function that I'm going to have to create. Let's focus on putting the getArea method together. Looks like I missed a curly brace here. There we go. All right, so what I need is to return a double getArea. And remember, this takes 3 points. So what we need to do is find the distance between all sets of 2 points to get the sides of the triangle. So for example, double AB is equal to a.distance. And if you want, you can call this point C for simplicity. Just know that C is the point, I should have mentioned this before, but the sides of a triangle are sometimes referred to by a lowercase letter that corresponds to the angle opposite the side. So the angle opposite side AB in a triangle would be angle C, so the side AB would be lowercase c. So lowercase c is the side corresponding to side AB, or the side between the points A and B. So double C is equal to a.distance to B. And there we go, and you can reorder these if you want. So we have found, using these formulas, the distances, the lengths of the sides. Now here's where I want to know if they're all in the same line. If C plus A is equal to B, then we just want to return 0. And the reason I wrote it this way, C plus A equals B, is because C is A to B, then A is B to C, and it's easy to visualize. If you're looking at A to B and B to C, then you want to compare it to A to C. If they are the same, what that means is that they're all in the same line. So you just return 0. And if that's not the case, then the program will continue. And instead, you're going to now find the semi-perimeter. So we say double S, suppose, is equal to A plus B plus C divided by 2. That gives us the semi-perimeter, pretty simple formula. And finally, we want to return using Heron's theorem that I mentioned earlier. So return, that should do it. That should return the area of the triangle. And if it's not going to be a triangle because all the points you entered were in the same line, it should return 0, which will trigger some other action here where the output will be not a triangle. Now there's one more thing we got to take care of. I introduced this round function, and I want to be able to round, but I don't want to write the function for it, so I'm just going to go online and look for it. Java round double to 2 decimal places. Sounds good. And here's one. And it looks like, there we go, rounding doubles with big decimal. To round doubles to n decimal places, we can write a helper method. And it looks like we can use this big decimal class that's available that will probably need to be implemented or imported. So I'm going to copy that, and I'm just going to paste it right in here. And sure enough, it asks me to import big decimal because we haven't imported it yet. There we go, we've imported big decimal, and looks like we need to import this class as well. But there's one last thing we haven't done, and that's include a main method to run this program. The first thing we need to do is create an instance of application. So I'm going to say application is equal to, or app, give it a name, is equal to new application. We have to now create a listener for the other button that clears the form. But before we do that, let me do one more thing so I don't forget that in the end I need to add a main panel to this J frame, and then I need to set visible to true. All right, so now let's get to creating the other action listener by going back to the form. So I'm going to right click, clear form, and go to create listener as we did before. It's another action listener. So now what I need to do is clear the form, and that's actually pretty easy and repetitive. I can just say point a underscore x underscore text dot set text to empty string. All right, so we've cleared the text, and it just reminded me that we haven't actually set the output. Here we create a string, the area string, but we haven't actually set the output pane's text to do anything with it. So finally, we can set output pane.set text to triangle area, and this should take care of it whether or not you made an error. If you made an error and put all of the dots in a row in a line, you should say triangle area, not a triangle. If not, it should get the value of the string once you round it to 4 decimal places and put that there. Let's go ahead and run this and see what happens. So the program is running, the form is up, and I'm going to enter a triangle, let's say 1, 0, 0, 1, and 0, 0. This is a triangle with a right triangle with the right angle at the origin, and it's one length on each side. And using we could use Heron's theorem here, but let's use the simpler 1/2 base times height. This would be 1/2 times 1 times 1, so the area should be 1/2 or 0.5. I hit calculate area, and there we have it. Triangle area is 0.5. So that's really cool. Let's see if a clear form works. That works. Now let's put in something that doesn't work, like A, or the letter Q, and then 1, and then 5, 1, and then 4, 2. Please enter numeric values only. So it caught the error. That's wonderful. What happens if you don't enter anything? It gives us the same error, and you can fix that to catch when all the fields are blank and display a different error if you wish. And then if I click X, the program ends. Let's run it again and see what it does with different inputs. I'm going to go back here and click run. And let's try 0.8, 2, or 3, 5, 1, -2, 0, or 0. There we go. And it gives us a triangle area of 9.1. That's really great. Let's see what happens if we do points that are obviously in a line. 1, 0, 2, 0, and let's say 7, 0. Not a triangle. So everything seems to be working. And let's see, did we catch every possible... Yes, we caught every possible input. We put in valid points, points in a line, no points at all, and then points where we have a letter or something like that, invalid input, and they all seem to work. Let's wrap up and talk about what we've done here. Back in the GUI form designer, let's see what we've done here from the beginning. We were able to use a designer and not worry about the code. We created a JPanel, and inside we put several widgets. For example, JText areas, such as these, where you enter the, JLabels for displaying some information, JText areas for inputs. We put an output pane here that's invisible right now, but that's where the output went, and some buttons. And for our buttons, we added some functionality. Let's go back into the Java file that the form is associated with, that's bound to the form. And the cool thing is, when we put widgets on the panel, the actual fields for those widgets were automatically added to the application.java file. Then we extended the JFrame class, and from there we were able to create a class constructor for our application where we called the JFrame super constructor to create its size and default operations. And we have these action performed listeners for the buttons. We have a get area method. We leveraged the point class to create points from the user inputs. We modified it to use double as inputs and double as output. We created a distance to function to find the lengths of every side of the triangle. We've done a lot of things in this one program. We implemented mathematical functions such as the Heron's theorem and the distance formula. We even found a function online that we needed to round, did some research, and found this function to round numbers. And finally, we added the main panel and set it visible. And in the main method, we just created a new application, and that's got the ball rolling when we hit run. So a lot of things went on in this file, but we broke down the problem step by step. We talked about how we would approach solving the mathematical problem. We talked about how you can size a form and get it to looking the way you want with a flow layout. We didn't talk about the other layouts, but we could, and they basically lay things out in a different manner. And this is something you should be really proud of. This is an this is an application that will work. It's ready to use. It may even help you with homework or your kids' homework. Well done. Congratulations. Let's go conclude. All right, I hope you all enjoyed going through that video and building that geometry application. Well done on getting this far. So just to review, I've got up here on the screen what we looked at. I won't spend too much time on this because we talked about it during the video, but suffice it to say we built an application that you can actually use, or perhaps your children who might be in geometry class. One thing I want to stress is that what you want to do when you're programming is to solve a problem first, then write the code. And we did that here. We stopped the programming in the middle so that we could talk about solving the problem of finding the area of a triangle given 3 points. Once we solved that problem, we were able to go back and quickly write the code necessary to find the area. And in the next video, we're going to transition away from Java to solving problems in Python, because as I said at the outset of this video series, programming is not about languages, it's about solving problems. And that's what we're going to do in Python next. And you'll be amazed at how easily you can do something in a language maybe you've never seen before. If you're following my videos, then all we've done is program in Java. And we're suddenly going to program in Python, and I'm going to show you that you're going to be able to do it regardless of whether you have any experience in the language or not. First is the temperature conversion graphical user interface application that we previously made in Java, where you enter a Fahrenheit temperature, you press a button, and it'll tell you what that temperature is in Celsius. So thanks again for watching. Subscribe if you like what you see so you can know when the latest videos come out, and I'll see you next time.